Today we are going to talk about median and we are going to concentrate on continuous frequency distribution. Okay, so continuous frequency distribution. Before going to continuous frequency distribution, let me talk about median, our normal median. So we all know that median is the middlemost number of a given series of observations. So let me give an example. So let's take observation as 25, 20, 15, 35, 18. These could be any observations, and the first step is to arrange them in ascending or descending order. So let's arrange them. So 15, 18, 20, 25, and 35. Yeah, and if we look, we can see that 20 is in the middle, so our median is 20. 20 is our median. Okay, now let's talk about a frequency distribution table. How to find the median from a frequency distribution table. So let me draw my table. This is X, this is F frequency, and this is CF or cumulative frequency. Let the observation be 1, 2, 3, and the frequency, let's say 5, 6, maybe 5, 6, and 4. Okay, so cumulative frequency is just adding up the frequency. So first is 5, then 5 plus 6, 5 plus 6 is 11, so 11, then 11 plus 4 is 15. Now the sum of the frequency is 15, so we write 15 here. And what is n by 2? N by 2 is like the total sum by 2, so 15 by 2 equal to 7.5, right? And if you look at the cumulative frequency, what's just below 7.5, that's 11, and the corresponding value of 11 is 2, so our frequency also, so our median is 2. Okay, now let's go to the continuous frequency distribution. In continuous frequency distribution, we will be given intervals, right? So let's take 0, 5, 5, 10, 10, 15, 15, yeah. So it will be given in the form of intervals. Let's say the frequency is 6, 7, and 8. Let me try to draw it in a better way. So this is my graph of the cumulative frequency. So y equal to CF or cumulative frequency, and this point on the x-axis is one of my intervals. Those represent one of my intervals, and okay, and let me draw this as a triangle, and the middlemost point is most likely to be our median, right? This is a median. Okay, this is interval is my median class interval, right? So let's mark the lower limit as L. Let me mark the points as A, B, C, and D, E, and F. Cool. I want to find AD basically, right? Because L plus AD will give me my median, like, right? So let's try to use geometry to figure out AD. So let me write median equal to L plus AD, and AD is unknown now. Now let's look at triangle EAD. Now EAD, triangle EAD, is actually similar to triangle CAD. Why? Because AAA angle CAB and a 90-degree. They share those two angles. So I can write AD by AB is equal to what? ED by CV or BC. Okay. Now what does that give me? Let's mark my CL as FK minus 1. A capital F represents cumulative frequency. Okay, so capital FK, CF, that's CF, and E of that median point is N by 2. Now from here I can write AD is equal to, let LF be H. So AD by H is equal to ED by BC. What is my ED? ED is N by 2 minus FK, right? Capital F K minus 1, and BC. BC is F of K minus F of K minus 1, and that's N by 2 minus F of K. K minus 1 by, what is capital F of K minus capital F of K minus 1? That's our frequency, right? So let me denote frequency by small f, so small f K. So that's pretty much it. We'll get our value of AD equal to H by F of K, small f of K, into N by 2 minus capital F of K minus 1, and our median is lower limit L plus, so our median is L plus H of small letter f K, frequency K, into N by 2 minus capital F of K minus 1. That's it. Let's talk about mode, and we'll be talking about the continuous frequency distribution of mode. Before that, we will discuss what the mode actually is. So the mode, as you all know, is the observation that comes the most number of times. So for example, we have 1 2 3 3 2 2 5 1, then 2 comes 3 times, right? So 2 is a mode. Now let's talk about uh, the frequency distribution table. So let me try to make a graph. So this is for continuous frequency distribution. So this is my graph of, say, observation versus the number of times it occurs, and this observation is the form of intervals, right? In cumulative frequency we have intervals. So suppose now let's mark that the interval points of as xk minus 1, xk plus 1, and xk plus 2. Okay, now let me try to mark this. Let me draw a diagonal like structure. Let me let me join these two things, and we see that the two dotted lines intersect at a point, and that intersection point actually gives us the mode. So this point right here is our mode. So let that length, the length till xk, and the length after xk be x. So essentially what my mode is Let me draw a bigger diagram, that's better. So here is my better diagram, and let me mark the point which gives us the mode. So that point over there gives us the mode. Let that angle be theta, and we know that the lines are parallel in a graph, right? So because of that we have vertically opposite angles, in corresponding angles, and we mark the angles as theta and phi. Let me mark the points that's better for understanding. So before that, the red line is what we need to find, right? Because xk plus the red line gives us the mode. So I'm marking these as A, B, C, D, and I'll let this be L, N, and M. So Lm is our unknown, and that's what we need to find. Okay, so what's tan theta? We had two triangles with theta, right? So in triangle, which triangle should I take first? So the two triangles with theta are LMA and MNB, right? So LM by LA is tan theta, and in the other triangle I have MN by BN. Okay, now let us look at the other angle phi. What is tan phi? We have two triangles again. So tan phi, if we look at the first triangle, that is DLM, we get tan phi equal to LM by DL, and in the other triangle, which is CNM, tan phi is MN by NC, MN by NC, or CN. Okay, from this, what we can do is, what do we need? We need LM. Okay, we can find LM. So LM by MN is equal to and LA by BN. Now what we are going to do is we are going to use a property. So the property is also the ratio is equal to DL by CN, right? DL by CN, and we can write this as, like, if A by B equal to C by D, then I can write, if A by B equal to C by D, then that is also equal to A plus C by B plus D, right? This is actually a formula. We are going to use this here, so let's use it and let's see what we get. So when we use this formula, we have Lm by Mn is equal to La by B, La plus CD, DL plus Bn plus Cn. Now that is equal to, if we look at our diagram, we have AD by CB, right? Yes, that's what we are left with. So x, I am marking that as x, our unknown Lm, and let the width of our class or interval be h. So Lm, we have x by h minus x equal to f of k, or fk minus f of k minus 1. Fk is the frequency basically, so we have fk minus 1 by fk minus fk plus 1. Let me draw this in the graph. So my BC is fk minus fk plus 1, and my dA is fk minus fk minus 1. Please note that fk is greater than both fk minus 1 and fk plus 1. That is why the mode lies in this region, right? That's why we are using fk minus fk minus 1 and fk minus fk plus 1 to keep everything positive. Okay, so our work is almost done. Now all what is left is finding x. Let me clear up some space. We have x plus h minus x by f of x minus x equal to fk minus fk minus 1 plus fk by fk plus 1 minus fk minus f of k plus 1. Basically, I added a 1 on both sides. That will eliminate the x. So I have h, and let me take the reciprocal. H minus x by h is equal to, what am I left with? I'm left with fk minus fk plus 1 by 2 fk minus fk minus 1 fk plus 1, right? Let me write it on top. So I have x minus h minus x by h is equal to fk minus fk plus 1 divided by 2 fk minus fk minus 1 fk plus 1. Okay, let me bring the edge to this side and this edge goes to the other side. Or let me bring the big term to the left side. So I'll get x as positive, and x is equal to, what am I? What do I get? I get h minus h into fk minus fk plus 1 divided by 2 fk minus fk minus 1 minus fk plus 1. So that is h into 2 fk minus fk minus 1 minus fk plus 1 minus fk plus fk plus 1, the whole divided by 2fk minus fk minus 1 minus fk plus 1. I think something or the other will get cancelled. Yeah, the fk, yeah, 2fk and fk goes, and I'm left with x is equal to h by fk minus fk minus 1, because fk plus 1 cancels, 2fk minus fk minus fk plus 1. So our mode finally comes to this mysterious L plus h into f of k, or fk minus 1 divided by 2 fk minus fk minus 1 minus k plus 1. This is the formula for mode. If you have any queries or questions on the subject, kindly write them in the comment section below. I will try to discuss the relevant ones in my next video. Also, welcome any suggestions on this video. Signing off, Madhu CS. Bye.